All right. So in our last class, we managed to talk about the transformations that we need to work with in our syllabus, like all the transformations, the six transformations that you need to know. Now we are going to have a continuation working on the translation. Like I said on the introduction, translation, it follows, or it is under the part of the isometries, that is the figures which are congruent. Remember, that is where we took this one from, when the two figures are congruent. So that is the first thing that you're going to need. That is one, the object and image are congruent figures. So we are going to say that the object, in this case, the object and image are congruent figures. So the moment that you see the object and the image being congruent figures, you think of, this is the first thing that you're supposed to think of. By just being congruent, you don't conclude to say this is a translation. No, you don't conclude like that. Because we also have a reflection there where the two figures are congruent. We also have a rotation there where the two figures are congruent. So we cannot conclude to say this is a translation, this is a translation. No. What will make this to be a translation now is this. Remember, the object and the image, they are congruent. So if you were to join, let's say this is your object, this is your A, B, C. If you were to join the point A to its image point, the point B to its image point, the point C to its image point, like you are joining these to the image triangle. Let's say this is our image triangle, like that. You've joined, maybe this is A1, this is B1, this is C1, where the object is where you're starting from, like from this is your object. Like you'll be asked, like, describe the single transformation which maps this onto another object. The one that is onto is the image. So let's say this is the, we call this the image. All right. So you're going to call this the image. Then this being the object, which is the object is the triangle that you are referring as your starting point. This is where you're starting from to this triangle. So if the two figures or the two triangles that are there, they are congruent, the first thing that we can see, that we can conclude in our mind, is that these are isometries. So it's either, it is going to be, it's going to be one of the isometries that I'm having there, which is the translation, the rotation, the reflection. But now what separates this translation from the other two is that when points are joined, A to A1, B to B1, C to C1, when these points are being joined, you are going to produce parallel lines of equal length. Okay, let me write it down. When corresponding points are joined, let's just say that way. When corresponding points are joined, so you've joined the corresponding points. So when the corresponding points are joined, we are going to have these parallel lines of equal length are produced. That is the idea there. They are not just parallel, but they are of equal length. Remember, parallel means these will never meet. So these lines will never meet. So these are the lines that I'm saying. They will be of equal length. If you join from A to A1 like this, B to B1, C to C1, you measure even by just looking by sight. You see that they are of equal length or not. You will see that. So if they are parallel and of equal length, therefore you can conclude now to say this is a translation now. Guys, be careful. All this that we are doing is to recognize our transformation. We are still recognizing. So you join A to A1, B to B1. By joining now, you see, okay, these lines, they do not meet, they are parallel, and they are of equal length. Now you conclude to say this is a translation. This here is not to be written anyway. It must be in your mind, this part. It's supposed to be in your mind. This is you and your mind. You don't write it down anyway. Once you have seen this now, that, okay, the object and the image are concurrent, I can see that I've joined my points. I can say, okay, I've produced parallel lines of equal length. There you need now to describe that transformation, which is our translation. So they will ask you to describe this part of joining it. All this, it is when you are asked to describe the transformation, you are asked to describe. So for you to describe, you must know the transformation before you start to describe. So now that you have seen, okay, this is a translation, this is how you're going to describe this. So to describe, let us just have this: to describe a translation fully. To describe a translation fully. We are now describing, guys, we are now describing this transformation that we have seen, that it is a translation. But how do we describe this translation that we are talking about, which is the transformation which occurred? So to describe a translation, you are going to state, you are the one who is writing this. You're now telling the examiner there, okay, you have seen that these lines, they're parallel. You don't tell you this one. You don't write this to the examiner to say, this is how I have seen. No, you describe by telling now the examiner the type of the transformation, that it is a translation. So you state that it is, well, let me just write it for you, because if I write state, someone is going to write state that. Okay, so you just write, it is a translation. It is a translation. That is the type of the transformation that is there. You now state the type of transformation. It is a translation. So on a translation, you do not just mention that is a translation. You also describe what is called the translation vector. So you also give the translation vector. You also need the translation vector. So you state the translation vector. The translation vector, which is our TV. I'm just going to write this in short. Translation vector, short for TV. So TV is equal to image minus object. So this is the formula: image minus object. Translation vector is equal to the image point minus the object point. This is the formula to find the translation vector. I don't know what I'm going to explain that there's nothing there. You just need to know this, like, okay, you've seen that, okay, the objects are the same, they are congruent, you've joined your lines, you see that they are parallel and equal. Now, when you describe, you are now stating it is a translation, then you state the translation vector. The translation vector is the one that I'm saying it is found by image minus the object. Image minus object. So I'm going to explain this in detail in the next examples. So let's see. This is what you need. Geometrical transformation is one of the easiest topics in our syllabus, if you know that. Okay, anyways, maybe, I don't know. Let's consider this. Question number one. Let's consider this. Question number one. Let's say we are given given triangle ABC. So in geometrical transformation, they can present a triangle in short like this. So given triangle ABC with the vertices at the points A, B, and so on. So with the vertices, let's say we are given the vertices, which is the point A, minus 2, 3. Okay. Let's say I've got the point B, minus 2, 1. And point C, okay, this is too much here. It's because of this. And C, which is minus 1, 1. Given this triangle, then the question is going to ask you to draw triangle ABC, this and that. You draw that triangle. Okay? Given triangle ABC, we mark those points. And also, you'll be given the image triangle and triangle, which is the image A1, B1, C1. So A1, B1, C1 with vertices, just like what we had there with vertices, which are the points, the vertices, which is A1. Let's say A1 is given as 1, 1, B1 is given as 1, minus 1, and the point C1 is given as 2, minus 1, like this. You're given two triangles. Then you're also asked to draw this. Draw triangle A1, B1, C1. You're asked to draw this triangle. All right? Then after that, the question is describe now. Describe the single transformation. Describe the single transformation. Describe the single transformation which maps, okay, which maps triangle ABC, which maps triangle ABC onto triangle A1, B1, C1. Okay, so guys, this is it. All right, so let's consider this here. There are two triangles there, ABC, first ABC. So let's consider drawing our triangle, because at the end we need to draw triangle ABC. So to draw the triangle, you just have to mark the points, just like your normal algebraic graphs. You mark these points. A, it's a point, meaning to say we simply talk about the X and Y coordinate, X and Y. So let's mark, we're gonna need the scale. Also the scale, we can have 2 centimeters to represent 1 unit according to this part that I just prepared so that we can understand each other. I'm gonna use 2 centimeters to represent 1 unit. That's 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Minus 1, minus 2, minus 3, minus 4, and so on. So these are the values that you're going to mark on your Cartesian plan. This depends with the scale that you are given there. That's 1, 2, 3, 4, and so on. All right, 5, 6. Okay. I want you to be very, very careful there. You are going to mark these points, okay? Let's start with the first one. That is triangle ABC. The point is minus 2, 3. For you to just do this topic, it means somehow you had algebraic graphs. You can't be doing transformation when you do not know even to draw a straight line. That's a greater mistake. If you do not know the part of your graphs, the Cartesian plane, just leave this video, work on other graphs for now. All right, because you need those the idea there. Okay, so I'm not going to explain about that. I just want us to focus on the transformation. So we're going to mark our point minus 2, 3. Okay, that is the X value is minus 2 and the Y value is 3. That is what we are given there minus 2, 3. Minus 2, 3. The x value is minus 2. 3 for y. So where these two meet, remember, from those algebraic graphs like I was explaining. So meaning to say the minus 2 and the 3, they will meet at this point. You mark that point. That's your point A. All right, the point B was minus 2, 1. If you still remember, minus 2, 1. So you're going to have minus 2 versus 1. You mark your point. That's your point B. The point C was minus 1, 1, minus 1 versus 1. You mark your point. These are the points. These are the points that you are given. So definitely what you're going to do is to join from B to C, from this to the, using your ruler. All right, so because of these constructions, guys, if I try to have a ruler here, it's going to take us a lot of time. So let me just do this way, but it's one and the same. So you were supposed to join your points, all right, from B to point C using the ruler now. You are joining there using the ruler from B to C, all right? So don't mind these guys. Like I said, you do the same from B to A. You are using your ruler there. You join these points. Okay, you do the same thing from this point up to this point. All right, you are joining your points like that. That's your triangle ABC, this one. This is the first triangle that we're given. We do not know, is it the object or is the image? The object image, it is something that is controlled by the question. It's not to say the triangle that you draw in the first place. No. They can ask you to describe the transformation which maps triangle A1, B1, C1 onto triangle ABC. The transformation that is being asked there is the one that controls our question to say this is now our image. So now we do not have an image or object. It's just a triangle, this one. It's just a normal triangle. Let's move on. Then we've got triangle A1, B1 with the vertices A1, which is 1, 1, B1, C1. So you mark the points just like the previous case, then you draw. All right, so let's start. A1, that is 1 versus 1. We're going to mark our A1, 1 on X, then 1 on Y. You mark your point. So that is your A1. All right, that's our point A1. So we're just going to mark even aside here. The point B1 was given as 1 minus 1. That is, X is 1 and Y is minus 1. You mark your point. These are the points that we are given on top there. The point C1 was given as 2 minus 1. So you're going to mark 2 versus minus 1. That is your point C1. Then again, like I said, you need to join now these points, just like the previous case. So you're going to join from this point up to this point. You join from this point up to this point. You join from this point up to this point to formulate your shape or to triangle at the end of the day. There, we do not know which one is the object there, which one is the image. Now, for now, we do not know. If we've just drawn like this, we do not know. Like I said, it is the question that is going to specify that question. So what is the question now? The question is, describe the single as just one. They are not, there's not going to be two transformations that are occurring at the same time. No, just single one. Describe one transformation which maps, that is where we are getting to the object image concept. Which maps triangle ABC onto this, onto. So this is the one that is being transformed. Which maps, guys, it's like there's a triangle that is there. It is mapped onto this. So that is where we are getting the object image. So meaning say this is your object. This is your image. So don't say, here it's A1, B1, C1, so that is my image. No. It's not like that. This same question that we are doing, the question, guys, these questions can be asked like this. They can ask you to describe the transformation, the single transformation, which maps this one, A, B, C, this one, onto this. So the moment they say this onto this, it means A, B, C is no longer our object. A, B, C is now the image. The one that is onto is the image from this object. So A, B, C is your object. The object is where you are starting from. The image is onto. You have transformed it to. All right. So now we have seen now, we now know that this is our object, this one. Okay, in exam, don't shade. I'm just doing this so that you see, but do not share this, okay? But unless you just want to see what you're doing. So the question is now, you are asked to describe this transformation which maps A, B, C onto this triangle here. All right. So I say that, guys, now let's be in class, because that is where our transformation is starting. That here, when we are on the diagram, when we are on the graph, that is where the transformation begins. So by looking into these two figures that we are having, the two triangles, we can see that these two figures, they are congruent. If my sight serves me well, this triangle and this triangle are the same. You don't need a ruler to measure from here to, guys, here is a box from B to C, a box from B1 to C1, a box from B1 to A1, 2 boxes, from B to A, 2 boxes. Then this definitely is going to be the same. A right angle triangle, as you can see, these two triangles, they are not similar. They are congruent. To be congruent, that is of the same size, same shape. The size is maintained. Shape is also maintained. So if truly that triangle ABC, this is our object, and A1, B1 is the image, and they are congruent figures, isometries. Guys, I said there are 3 answers to be taken. Of those 3 answers, for you now to realize that it's a translation, it must be parallel lines of equal length when corresponding points are being joined. That is where we can conclude. But for now, at this point, there are 3 answers that I'm expecting here. By just being congruent like this, there are 3 answers. What is it? Translation. Don't conclude this. There are 3. Translation, reflection. Remember what I said on the introduction. That's why I said watch the introduction. Rotation. Remember I said about these 3. These 3 transformations, they are called isometries, where the object and the image are congruent. There are 3 transformations. Each has got its own property. So now, in order for you to finalize that it's a translation, you are now finalizing now that it's a translation, or it's a reflection, or it's a rotation. How do you finalize? This is where now, when you join the corresponding points, so you need your ruler there. Yeah, because of this, guys, if I try to use my ruler here, it's going to affect me. So I'm just going to use this one, but as a broken line. So that is where you join now the corresponding points. All right. So I'm going to do it like this. You join point A to point A1 using your ruler, A to A1 with broken lines. All right. A to A1. You do the same thing, B to B1, like this, B to B1. C to C1, like this. You are joining using your ruler. You join A to A1, B to B1, C to C1. When you have joined these points, and when you are joining, use broken lines like this. Don't use continuous line, because if you use continuously, it's like you're forming another shape. Now, what are you seeing on this part? You're seeing that these lines that I'm seeing here, guys, no matter what, these lines will never meet. These lines will never meet. They are parallel to, no matter how you're gonna extend. They are made these. Let's consider these two here. These two, the first two. Look, there's equal distance maintained throughout. If you check these two here, there is equal distance maintained throughout. This is to mean this line here is parallel to this one. This one is parallel. They are parallel lines. But it's not just to end there. No, it's not supposed to end there. You must measure the distance that is maintained, because we need to know that. Okay, here I'm just going to try to do this. Let me show you another way of measuring. Instead of you using your ruler, instead of you using a ruler in measuring, you can use this this concept of this compass concept. You mark, you mark, you put the needle point. Okay, let me just try shift a little bit like this. This is what you do. You place this needle point, this on your compass, this needle point at A. Okay, so you're gonna place the needle point at A. Okay, you place this needle point at A like this. Then you take it to the point A1. Okay, like this. This is A to A1. A to A1. Are you seeing it? This one. So this part here, from here to here, it represents A to A1. So for you to know that these are of equal length, you move this compass to the point B to B1 without changing that distance. You're just moving it and see if it's going to maintain. Let's move on. B to B1 and place it there. If you place it B to B1, are you seeing it is exactly of the same length? It is that's the same length. You move it C to C1. You place it like that. See, are you seeing it's the same length? So this is to show us these parallel lines are of equal length. So you don't need to put a ruler now. You take a ruler and you start. Yes, you can do that. You can take, because remember, this is geometrical transformation. Once you talk of geometrical, this is supposed to be there. Your math set is supposed to be there. You're supposed to have your mathematical set. So you just place your, you can even use a divider. You see that divider with the needle point, where it has a needle point and a needle point there. So you just place a needle point on A, the other needle point on what? On A1. That alone is enough. You move it from C to C1, okay, it's the same. You move it from B to B1, it's the same. There you can easily measure to see, you can easily see that these parallel lines are of equal length or not, or you can use your ruler. All right. So this is it. Guys, let's conclude. We measured here, or we joined A to A1, B to B1, C to C1. We produced the parallel lines that are of equal length. That is where we conclude to say it cannot be a reflection. We're going to talk about reflection. You'll see that it's not a rotation, it's a translation, because it is the one that produces parallel lines of equal length. When corresponding points are joined, from where? From congruent figures. When these points are joined, parallel lines of equal length are produced. That is where you conclude now to say it is a translation. You are now describing. So the question here was, let's go back to our diagram. The question here is, describe the single transformation which maps triangle ABC onto triangle A1, B1, C1. So we have concluded from all these constructions that we had. So now we are describing it is a translation. This is to describe. It is a translation. So this all part, you are showing it on the diagram. You do not tell the examiner that I have joined the point A1 to B1, A to A1, B to B1. I have seen that these lines are parallel. Therefore, it is a There's no mark for that. The first mark that you're given, it is a translation. That's a mark. Yes, there's a mark to draw this triangle. You'll be given a mark to draw this triangle. That's a mark. These constructions, there's no mark. It's just for you to know, okay, now I know this is a translation. So there's a mark there just to name it is a translation. Then another mark is the translation vector. Remember, to describe a translation fully, to describe this fully, you will need also the translation vector, where I said the translation vector, it is the image minus the object. Image minus object. So we are going to need the translation vector, or you can even write TV. So translation vector, if it is given as the image minus object, this is the image triangle, this is the object triangle. So when I'm saying image minus object, I'm saying the point on the image. So if I use A1 on the image minus its corresponding point, which is on the object, is what? It's A. That's what I'm trying to say. Image minus the object. Image minus object. So the image, that's A1, or you can use B1. So you write it as a vector. Let's start with A1. We're going to use another one and prove. So A1, you write it as a column vector. But guys, vector. It's not a point. Remember, when you were working with vector 1, you were expressing a point A as a column vector, where I said you just have to take the point as it is. So you just take your point A1 as it is, but as a column vector now. Our point A1, remember, it was 1, 1. That was our point A1, 1, 1. But you just write it as a vector now, 1, 1. Minus A as a vector. The point A was given as minus 2, 3. Remember, you can even take it from your coordinates, minus 2, 3. That is our point A, but you write it as a vector. So if you subtract this 1 minus 2, that's 1 plus 2, which is 3. 1 minus 3, 1 minus 3, that is what? Minus 2. So this is our translation vector, TV. So these are the two things that you need on a translation. It is a translation, then you state the translation vector, 2 marks for that. So imagine you've got 4 marks. To draw this object, to draw the image, to state that it is a translation, to state the translation vector, it's a mark. So this is what you need. All right. So like I said, the translation vector, as long you take it, the object, image minus object. Let's say you decide to use B1. B1 is on the image. So if you use B1, you are going to subtract B. B1 minus B. So what is the point B1? B1, remember, it was 1 minus 1. 1 minus 1 minus B. We must have the same answer. The point B, it was minus 2, 1. This is minus 2, 1. If we subtract 1 minus 2, that's a positive 3. Minus 1, that's a minus 2. So as you can see, we are obtaining the same translation vector. Even if you use C1 minus C, you are going to have the same answer there. Same answer. So you can even use C1 minus C. What is the point C1? 2 minus 1. 2 minus 1 minus the point C, which is the object, minus 1, 1. So if you subtract this, you're going to obtain 3 minus 2. That's the same translation vector. So that's to describe a translation. To describe a translation, this is what you need. This is what you are going to need to describe. So you need to be very careful. Very, very careful. All this is required. All this is required. So if you are someone that is to understand this much better, like I said, be watchful and make sure that you follow up. So we are going to have a follow-up exercise after this. we are going to have a follow-up exercise on our translation. We're still on the basics. Make sure that you watch all the videos up to the end so that you do understand. But for now, that's it. Till we meet again.